So in naming binary molecular compounds, when you get to tests or quizzes, your first big decision is what set of rules to use. Should I be using the stock system, naming the cation or the anion, or do I have a molecular compound and you're going to start using these prefixes, mono, di, tri, tetra. Okay, we never denoted counts before with the ionic compounds. You just do these with the molecular. Okay, so for ionic, your 99.9% of your questions that are ionic are a metal and a non-metal. So that's what you're looking for to name the two ions. With binary molecular compounds, binary means two. So we're naming molecules that have two different atoms in them. They're molecular compounds. These are now when we have shared electrons. I did that carbon dioxide example where they were sharing electrons yesterday. Okay? This is going to be when we have two non-metals, okay? Like carbon and oxygen in a couple of different forms. Okay? So you see CO, okay, two non-metals. This is not ionic. These guys are going to share electrons amongst each other. Okay? You have to have these guys, and this is something we'll talk about next year in Chem 20, all these non-metals really want to suck in electrons. Great attraction for electrons. Okay? These over here, weak attraction. So you need a strong and a weak to become ionic. Okay? Here, these are like two strong people in a tug of war and all they do is stay in the middle. Okay? They end up sharing. So two non-metals, you use these prefixes. Okay? I didn't write out all the rules. I'm just going to talk about them. But some students may want to make some extra bullets in their notes about the rules that I haven't typed out. Okay? Most of them are the same, which is why I didn't write them out. Okay? We're going to do the same as we did before. Name the first part, but it's not an ion anymore. We're going to name the first element as is. We're going to name the second one, switch the ending to "ide." But then when it's sharing, we use prefixes to say how many there are. Okay? There are no charges here to balance anymore, so we can't predict count by balancing charges. We have to tell the reader how many there are. Okay? So I'm going to start naming. The only other twist we're going to see is we never start with mono. I'll actually... So if we only have one of the very first atom, we leave the mono out. Or if you have a question and there's no prefix, it's missing at the beginning, you realize there's just one of them. And that's what we have here. We've got carbon, there's just one of them. So we write the carbon exactly as it would be in our periodic table. We don't put a prefix because there's one of them and we don't start with mono. The second part always gets the mono if it needs it. It's only the first that we drop it. So carbon, we've got oxygen. Okay. Like before, we drop the ending and go to IDE, but now we need a prefix. There's two of them, so we're going to have to put in di. Carbon dioxide. Okay. And it's certainly a term you're probably quite familiar with. You just maybe didn't know that was the IUPAC name, the proper scientific name for it. Okay? A lot of times we use trivial names, not IUPAC names. Okay? I'll switch to carbon with just one oxygen. Okay? There's only one carbon, so we don't write the mono. We just go right into carbon. Okay? Now we have to write the mono. We always use a prefix for the second one. It's oxygen again. We drop the ending. We switch it to IDE just like before. We use a prefix for one, which is mono. Now I'm just not going to write this last O. When you have back-to-back letters or often back-to-back vowels, one of the vowels gets dropped. When you're doing tests or quizzes, that's not what I'm after being picky about. So if you did a quiz and you put in the two O's, I'm not going to take marks off right now while you're learning, but you don't put those two O's there. The way we do it is just to use the one. Okay? So we get these quirks to the naming rules when it creates words that just the pronunciation is not fluid. Okay? And back-to-back vowels is the typical thing that causes that problem. Or back-to-back similar sounds like a Y and an I. So that's 2 examples. NO3. Now I was hiding a few of the last prefixes. So it's mono, di, tri for 3, tetra for 4, and then we're into a lot of our shape prefixes. Penta, hexa, hepta, octa, nona, and deca. Hopefully these are familiar from your pentagon shapes in elementary school. So NO3, okay, there's no metals here. Okay, so this is going to be sharing, so we have to use our prefix naming rules. First part is nitrogen. We write it as is. There's one of them, and we don't start with mono. Then we have oxygen, so that'll be oxide, and there's 3 of them, so trioxide. With the second part, we're dropping the ending and switching it to IDE. Now, one reason I did this example is chemistry notation can be really picky on one little subtle change. I just did NO3, which is a molecule. Okay, I'm going to go versus, which is very different than NO3 minus the nitrate we just looked at as an ion 10 minutes ago. Okay, so this is a polyatomic ion where that is just a molecule. Okay, so if you're ever doing a test and there's a little speck or dot there and you're like, hey, is that a minus or is that just a blip on your paper, make sure you ask. Okay, or just don't see NO3 and go, hey, I know that, I remember that ion. You know, this and that are totally different. 2 more examples and then I'm done. Do you need me right away? Okay. So SF6. Okay. Again, we have a lot of these examples where the first atom has just one of them. So write sulfur, don't alter it. Our F, we've got 6 of them. So we have to use hexa and then change the ending to IDE. So sulfur, hexa, fluoride. My last example, I wanted to get something in that doesn't have a 1 at the start. N2O4. So in this case, we have 2 nitrogen. So I have to tell the reader how many there are. Again, do not use charges for the N and the O. Okay? They are not charged. Okay? Don't try to balance them. Dinitrogen. Then there's 4 oxygen, so tetra. Oxide. We're always changing that second of 2 non-metals ending to "ide." And that's my last example for binary molecular compounds. Okay? So we're just dealing with 2.